Hello everyone, today we are going to talk about how to do a Procrustes rotation in R. What is a Procrustes rotation? It's a way to assess concordance between two principal component analyses, or PCAs. Essentially, it's a way to determine similarity. If you're not familiar with how to do or interpret a PCA, I suggest looking at my other video on how to do a principal component analysis in R before continuing with this video, since I plan to just breeze through the PCA part and focus more on the Procrustes. In our example today, I have presence-absence data on the amphibian species inventory and road mortality for different sampling sites. So for each site, I know which species there are and which species we have recorded being victims of road mortality, which is the slightly nicer, slightly more scientific way of just saying roadkill. I am going to use a Procrustes rotation to compare species inventory and mortality at each site. If they are concordant, that tells us that there's not much of a difference between the species present and the ones experiencing mortality. But if the PCAs are not concordant, that tells us that certain species are more vulnerable to road mortality than others. This is an example of how these methods can be applied for ecology research. Knowing the answer to this question could help the conservation of amphibian species or inform urban planning considerations. Now that we've set the stage, let's think about what a Procrustes is actually doing with our PCAs. The Procrustes rotation overlays both PCAs that you input and rotates them to maximize similarity. Remember from when we talked about PCAs, the axes themselves are just showing where there's variation in the data, so are fine to rotate to assess relationships between the points. The Procrustes rotates until the squared differences between corresponding points are as small as possible. From here, it generates vectors showing the magnitude and direction of the shift of an object from one PCA to another. So the larger the vector, the larger the difference, and the smaller the vector, the smaller the difference. This provides a lot of information on the similarities and differences of the species and sites between two PCAs. You can then assess the statistical significance of this shift using a protest, but we'll get to that in a little bit. Now let's look at our example in R. As always, set the working directory and read in your libraries. In this case, we need ggplot and vegan as our libraries. I'm going to quickly read in my inventory and mortality data frames. Remember, since my data is a matrix, I need to write row.names equals 1 as my first column contains the names of my sites. I'm going to NA omit both data frames just as a precaution to avoid any potential errors, and then run the PCA for each. Keep in mind that scale is going to be true for everything since I'm using presence-absence data, meaning my values are only a 1 or a 0, so it's already scaled. Remember, if you read the summary information of the PCA you just ran, you can see the species and site scores and the amount of variation explained by each principal component axis. Let's render the PCA biplots side by side so we can see what we're working with. We can put them side by side by using this par function with the coordinates set to 1, 2, because I want one row with two columns of plots side by side. When we run the biplot code, we see the relationships between species when we assess inventory and mortality. Again, the particulars of the PCA and biplot code and biplot interpretation is explained more in depth in my PCA video. So if we were to look at this, we could probably pick out some general trends and how the species relationships change. A Procrustes will do that for us much more efficiently and accurately though. So let's move on to our Procrustes. In R, the function for Procrustes is just Procrustes, and then you input the name of the two PCAs, so it's simple enough. I'm going to name this proc and run it. The plot for this is super simple, just plot and the name of your Procrustes. I'm going to want to add a little bit of text because I want the sites to be labeled so I know which vectors are which. When you render this plot, it seems like a lot's going on, so let's break this down. The vectors are representing the shifts in species inventory and mortality for each site, so each vector is for each site. Vector 22 for site 22 is relatively small, so that's telling us that for site 22 there was not a huge difference in the species that were present or absent and the species with observed row mortality. In other words, inventory and mortality are more or less proportional here, which is what would be expected if there is no species-specific vulnerability. But what we see with most of the sites is that they have really large vectors. For example, look at site 13. The vector is really large, meaning that there's a bigger difference between the species present and the species with observed mortality. Although we can look at this and say, wow, it looks like the species inventory and mortality are really different, unfortunately, we can't leave it at that when we're doing science. We need a p-value. So we can assess the statistical significance of the Procrustes using a Procrustean randomization test, or protest in R. So the function is protest, the name of each PCA, and then scores is going to be set to sites because we're assessing the inventory and mortality presence-absence for each site. We also set permutations to 999, which means that this is going to run 999 times. When we run this, we can see that the protest is not significant. But remember, we're assessing concordance or agreement. So our null hypothesis is that the data sets are not concordant, and the alternative hypothesis is that they are concordant. Since our p-value is greater than 0.05, we stick with the null hypothesis and say that amphibian inventory and mortality are not concordant across our sampling sites. As a researcher, this tells me that species-specific vulnerability is occurring, which prompts me to look into this further to see which species are more vulnerable. To summarize, today we discussed what a Procrustes rotation is, went through an example using 2 PCAs in R, and assessed the significance of our Procrustes analysis. Check out my page if you're interested in more video tutorials in R or QGIS. If you have any other questions or suggestions, please put them in the comments. I hope you enjoyed this video and found this helpful. Thank you for watching.